Hi friends, welcome to my YouTube channel. This is lecture number 11 and today we are going to study diode circuits and waveforms. First we will study DC source applied to diode circuit with RC load. Here load is resistive and capacitive and this load is connected in series with this diode. Now this is switch S and this is voltage source Vs. Okay. Here you must know this very basic equation of network theory, that is VCT is equals to Vc infinity plus Vc0 minus Vc infinity e to the power minus t by Rc. Here Rc is time constant of this circuit, that is equals to tau and that is equals to Rc. So time constant for this circuit is Rc. Now when this switch is closed at t is equals to 0, then what happens? For sudden change in voltage, this capacitor acts as short circuit. So Vc0 is equals to 0 because voltage drop across short circuit is 0. Now what happens at t is equals to infinity? At t is equals to infinity, when steady state is reached, in this case capacitor acts as open circuit. So at t is equals to infinity, what happens? This capacitor acts as open circuit. When this capacitor is open circuit, then this voltage Vs will appear across this capacitor, that is equals to Vs. So we simply put in this equation that this Vc infinity is nothing but it is equals to Vs, and this Vc0 is equals to 0 and this Vc infinity is Vs. In this way we get Vct is equals to Vs 1 minus e to the power minus t by Rc. So now we have to plot the waveform for this capacitor voltage. How we can plot this? So we know that at t is equals to 0, what happens at t is equals to 0? E to the power minus t by Rc is equals to 1 and 1 minus 1 is 0, that's why we get 0. At t is equals to infinity, this e to the power minus t by Rc will tend to 0. When this tends to 0, then we get Vct is equals to Vs. So this Vct will tend towards Vs when time tends to infinity. Here at t is equals to infinity, it tends to become Vs. Now what is capacitor current? We know that IC is equals to CdVc by dt. So we get Vs by R e to the power minus t by Rc. If we put t is equals to 0, then what happens? This is equals to 1 and we get Vs by R. Okay. Now what happens when t is equals to infinity? Now at t is equals to infinity, this whole capacitor current will tend to become 0. So here initially when t is equals to 0, this capacitor current is equals to Vs by R. Now when time tends to infinity, it will tends to become 0. So these are the waveform for capacitor current ICT and capacitor voltage VCT. Now we will see DC source applied to diode circuit with RL load. Here in case of RL load, the inductor current at any time t is given by IL infinity plus IL0 minus IL infinity e to the power minus R by LT. This is also very basic equation of network theory. Here this L by tau, that is time constant, is equals to L by R. Now when this switch is closed at t is equals to 0, then this positive potential is applied to this diode and diode gets short circuited. So When this diode gets short circuited, a sudden voltage is applied across this inductor L. We know that inductor opposes the change in voltage, change in current, because when this switch is closed, current will suddenly try to flow across this inductor. So when there is change in current, then this inductor will oppose this change in current and it will act as open circuit. So when this inductor acts as open circuit, IL0 is equals to 0. And what is IL infinity? In a steady state, inductor acts as short circuit. At t is equals to infinity, inductor acts as short circuit. And what is inductor current? When this is short circuit, we get current I is equals to Vs by R. So this inductor current at infinity is equals to Vs by R. So putting this, we get ILT is equals to Vs by R plus 0 minus Vs by R e to the power minus R by LT, and on solving, rearranging this, we get Vs by R 1 minus e to the power minus R by LT. And what is inductor voltage? It is simply LdIL by dt. On differentiating inductor current and multiply it by L, we get inductor voltage is equals to Vs e to the power minus R by LT. Now here, when t is equals to 0, then what happens? This e to the power minus R by LT becomes 1, and 1 minus 1 is 0. So we get inductor current is equals to 0. And when t tends to infinity, then this will tries to become 0. And when this is 0, we get ILT at infinity, that is equals to Vs by R. Okay. Similarly, for this VLT at t is equals to 0, this VLT is equals to Vs, and when t tends to infinity, it will tend to become 0. So in this way, we can plot the waveform. We get this waveform. Here, inductor current is Vs, inductor voltage is Vs when time is 0, and when time tends to infinity, this inductor voltage will tend to become 0. Similarly, in this way we can plot the waveform of inductor current. Now capacitor is charged to voltage VCO and polarity is shown here. Okay, now draw I and VC waveforms. We have to draw I and VC waveform for this. Again we will use VCT is equals to VC infinity plus VC0 minus VC infinity e to the power minus t by RC. Again use this very basic equation of network theory. We know that initially this capacitor is charged to voltage VCO. Reference for polarity across this capacitor is this, but it is charged to this polarity. So we will put VC0 is equals to minus VCO. Okay, and at t is equals to infinity, what happens? This is positive and this is applied to this diode, so this diode will act as short circuit. Okay, now at t is equals to infinity, this capacitor acts as open circuit. Now when this capacitor is open circuited, then there is zero current in this circuit. So we get Vc infinity is equals to 0. Putting Vc infinity is equals to 0 and Vc0 is equals to minus Vco in this equation, we get Vct is equals to minus Vco e to the power minus t by Rc, and Ict is equals to Vco by R e to the power minus t by Rc. Now we can easily plot waveform for this capacitor voltage and capacitor current. Here for capacitor voltage, this capacitor when t is equals to 0, then this capacitor voltage is equals to minus Vco. Here we see that it is equals to minus Vco. Now when t tends to infinity, then this e to the power minus t by RC will tends to become 0. That's why when t tends to infinity, VCD tends to become 0. Okay. Similarly, we can plot the waveform for ICT. So this is all about this chapter. I hope you really like the video, and thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.